Greetings and welcome to the second episode in our 2022 webinar series. My name is Dan Landy, engineer with the PE Alliance, and today we will be covering PE standards. A warm welcome and thank you to all of our members joining us today. We appreciate the support that allows us to do what we do and interface with municipalities, utilities, and consulting firms on platforms like the webinar series today. As always, we have platforms on all social medias, LinkedIn being the place where we post daily. Go ahead and give us a follow on the media of your choice. LinkedIn is the most popular. Really quick, our website, pepipe.org. If you're looking for case study info, you can either reach out to me or go ahead and register through our website and take a look yourself. We are always looking to feature new and innovative jobs, cool installations, etc. So go ahead and let us know if there's anything cool you're working on, and we would love to feature you on our website. Free resources, I covered a couple of these yesterday. And today I'm going to highlight project review and assistance because Alan Ambler, PE of the Alliance, is back to join us today. And he is more than willing to help you through some difficulties you guys might have on project specific concerns or just general adoption. We can always sit down with you face to face in that seminar format. And Alan does a fantastic job. Let us know when we can get something scheduled. You can reach out to me or Alan. Our information will both be on a slide coming here in a few for our contact information. And then additionally, I just wanted to touch back on the engineers package. A lot of people reached out for this yesterday. A lot of people already have it. But if you do not, send me an email. And if nothing else, it'll build out your HDPE library for when the time comes for you guys to begin that adoption phase. Upcoming shows, designing your next PE project. Alan will be here 2-1 to go through that, and that is a general broad format for new PE jobs. So that's a little bit higher view than it is for our seminars. But if you would like to address specific concerns, we can get on a seminar. If you ask me anything, PE will be the next week. That will be our other speaker, Richard Colassa, him and Peter Dyke. I get to interview them with a bunch of curveballs that they don't know I have coming for all the grief that man Richard has been giving me lately. And then 2:15, this actually wraps up very well. We'll be visiting Deanne Hughes, our head speaker today in Tulsa, Oklahoma, to see what is going on with the McElroy I series and how they are changing the industry through innovation. As always, stay up to date. Like I said, pepipe.org, our website. Thank you all for being here today in our webinar format. And if you are interested, the Poly Podcast, give us a follow on the App Store, Android Store. And if you can't find it, always available on our website. So today's team, Deanne Dutton-Hughes, PE, McElroy Manufacturing, will be the head speaker getting us through this presentation. She's given it many times. You might have seen her give it before, but PE standards is so dense. This is a great topic to visit multiple times. So thank you all for being here today. Alan Ambler, head engineer of the PE Alliance, and also his private company, AM Trenchless, is here. He and Matt Hahn will be answering a lot of questions and also be providing color with Richard Clausen. Thanks for coming on there, Matt. So if you any questions you guys have, whether they be civil, materials related, installations, we got a really good, solid crew here today to go ahead and answer those. And I'm going to go ahead and open the first Q&A to help Deanne understand our audience really quick. So today, the opening question is going to be, heading into this presentation, how familiar are you with PE standards? The options being, I am unfamiliar, I have a working knowledge, so you kind of know what's going on, but you don't know all the specifications, or you're sort of a master and you're here to stay up to date, which kudos to you for understanding things very well and still committing to the process. I'll leave this slide up, I'm sorry, for one more second to go ahead and give everyone a chance to screenshot mine and Alan's information. If you want to shoot me an email regarding PDHs, I can get that to you the quickest. We'll save the more difficult questions for Alan, so don't worry, Alan. I'll plug that. But project assistance, any questions you have, HDPE, go ahead and give me or Alan a shout. I'm going to go ahead and end this poll. And then I'm going to introduce Miss Deanne Dutton-Hughes. She is the Director of IT Systems and Industry Liaison of McElroy Manufacturing. Her IT role is focusing on deploying IT resources to solve business challenges, improve workflow processes, and implement strategic IT projects. Within her liaison role, Diane serves as a member of the industry groups and standards organizations, including PPI, ASTM, and AGA's Gas Piping Technology Committee. Thank you, Diane, for the continuing efforts you make to support the Alliance and everything you do. It is greatly appreciated. She is a registered PE practicing environmental engineering prior to McElroy in 2016. And you can see her contact email information. I'll leave that up for one more second in case anybody wants to screenshot it. And Dan, are you out there?
I am. Let me get all of the, let's see. Dan, will you make it so my video will work, please?
Okay, I just asked for you to share your video. And are you able to see the result of the first poll?
Not yet. You want to just tell me what it says?
Okay, I'm sorry. I was waiting for your video to come on. We have 37% of people headed in today are unfamiliar. 50% have a working knowledge, and 14% consider themselves having a very familiar with PE, but they're here to stay up to date. So pretty much a split right down the middle, but it's nice to see at least 50% of people have been working in our industry, in our field. So it seems like they have a lot to learn. And with that, I'll hand it over.
That's great. Well, then for those 14%, I'm looking forward to pulling their knowledge into this group as well. Yep, there it is. Awesome. All right. Well, so nice to meet all of you, and thank you for being here today, Dan. A great way to get us started. I'm a little worried about what color Matt and Richard might be adding to the day, but we'll stay tuned there as we go. So the first part of this presentation really deals with why do we have standards in the first place? And that really goes to the question of what do we do as an industry so that as our users and our public are using our product, that we know that there is consistency, there's safety, there's compliance, and there's reliability. That we're really looking to building an infrastructure that our public can rely upon. And that really drove quite a bit of the early work around how do we take high density polyethylene materials into the marketplace in a way that the market can receive it. And we have standards that really are a complete wraparound for HDPE, from the design phase all the way through how do we train people to use the equipment and to use the pipe, how do we install it, how do we test it, and how do we maintain and repair it. So really, whatever phase of the project you are working to support, there are standards out there that are industry-based, consensus-based. It is not McElroy saying this is how you should do it. There is an entire industry group that has worked together to arrive at some standards that we can all use as we work forward. So you hear a lot of words around HDPE. You hear standards and pipe and pressure and fittings and squeeze off, and there are lots and lots of topics. We are only going to scratch the very surface of this today. Everything that we talk about are not necessarily standards, but they are certainly a good basis for understanding the standards and for understanding the piping systems that can be developed and installed and support your municipalities with HDPE. So let's talk about the groups that are really working to support the development of standards and standard processes. Of course, we have the American Water Works Association, and we will start with their document as our first step out as we move into this presentation today. Let's see, I'm going to pull this over here so I can see it. There we go. And then we're going to also talk about the PE Pipe, the Alliance for PE Pipe. You know that group. Plastic Pipe Institute, ASTM, NSF also has some standards out there. And then we'll also talk about ASCE. Alan, you've got something you want to say?
Oh, yes. Sorry, we were remiss, everybody out there in the webinar, to highlight the Q&A function. The team here is to answer any questions as you go through. So definitely don't hesitate to give us that question that you might be having there as well. That's what we'll be looking for. Sorry to interrupt, Ian.
No, that's great. I'm glad you did. And I'm glad I pulled all the right pieces into the right screen here to see that. Okay, so many of these organizations you can join either as an individual or as an organization. It lets you be a part of the standard making process, and it certainly keeps you up to date on the activities that are happening. membership in ASTM, and we'll talk about several ASTM standards later today. That individual membership is $75 a year, and it gives you free access to the standards that are a part of whichever division that you join. So these are very accessible organizations, and we highly recommend that you join at least one of them, because it will keep you in the circle of opportunities to learn more. Of course, the Alliance for PE Pipe has seminars like today, which are always a good place to start. All right, I told you we'd start with AWWA, and here we are. They have updated their M55 manual. And as we go through today, you'll notice that I have flagged those things which have been updated. COVID has done a lot of really yucky things for our entire society and world. But one thing that it has also accomplished is all those projects that people had on their desk from the organizations that they belong to, and they said, yeah, I'll work on a standard for that. COVID has been great because people have been at their desk and not traveling, and a lot of things have gotten updated in the last 2 years. So you'll see this update sticker quite a bit in today's presentation. M55 is a prime resource, and definitely a resource worth having. You can buy hard copies, or you can download directly from AWWA, but this is absolutely one that you want sitting on your desk. And I think I saw it sitting on Richard's desk when he flipped his camera on earlier. So it was updated in 2020. It is AWWA's best-selling book, and for good reason. It really does provide soup to nuts. There you go. Thank you, Richard. Good job. It really is soup to nuts. What do you need to know about PE pipe design and installation? And it starts with the material itself, how the product is manufactured, and takes us through the hydraulics and pressure ratings, load design, heat fusion. So in my engineering career, we studied a lot of ductile iron, we studied a lot of PVC, we studied a lot of concrete. We didn't study a lot of HDPE in my engineering curriculum. And so, of course, the concepts are all the same, the equations are all the same, but what do we use when we get to those equations? The handbook gives you a really good starting place for the design of your system and how to go about installing it, because it is different. It discusses how you do mechanical joining, because even though the polyethylene portion of your system may be all heat fused together, you're going to still probably have places where you have to connect back to existing infrastructure, and that's going to be a mechanical joint. So how do you do that, and how do you anchor those? Fittings, of course we have fittings. We've got places we've got to get connected. What do those look like, and how do you do them? How do you transport, handle, and store that pipe safely and protect the people who are working with it? How do you test, how do you hydro test, and how do you commission a system? And then finally, how do you do maintenance and repairs? Richard, you got something you want to add there?
Yeah, and just keep in mind that, although the AWWA puts it in a written form too, all the manufacturers of the polyethylene pipe and fittings also have these documents as well. So you can solicit them as well. So you have lots of resource to rely on to make sure that you're conducting these practices properly.
Yeah, that's a great point, Richard. That one of my slides here later, I make the note that you do not need to be reinventing the wheel, that there are lots of people and lots of places to find the information that you need in order to arrive at a design and a construction plan that meets all the criteria and that will work for your installation. So lots of people and resources to use. AWWA M55 is just one of many. So in addition to that update in November of 2020, they added PE 4710 and all the properties of that pipe, so they're all in one place, and then the design considerations as associated with PE 4710. The disinfectant residuals, of course, we'll talk more about that later, especially with regard to C901 and C906. And if you don't know what those are, we'll cover it in just a little bit. And then it also updated those definitions for design factor, surge, just so that we have up-to-date resources for you as you're doing your design work. A couple other things that they added to their manual. They added average flow velocity values for both average as well as occasional surge. And they rewrote 2 entire chapters, both the external loads as well as the chapter 8, which to conform with some changes that ASTM has made. And they added an entire chapter for trenchless applications. We see trenchless quite a bit, especially when we're replacing existing infrastructure with existing infrastructure above and below and next to those lines that we want to replace. So trenchless, we see quite a bit of activity and interest, and AWWA heard that and added an entire chapter. A couple things they also did, they differentiated between a basic installation and an engineered one. And that was really a function of what size pipe are we working with, how much cover, what kind of loads do we have? Are they live loads on top? What are our backfill requirements? What are our soils like? They really helped an engineer separate between things that were a pretty basic installation and those which required a little more detailed engineering calculations. And they looked at chapter 6 on how you do joining and how you do fittings. And of course, repairs, we will talk about MAB4 here before the end of the session to help think about how you repair a system. And the big thing, and I especially appreciate this about what AWWA did here. So they've really rewritten an entire book. And sometimes those things that we rewrite, we get to the appendices and we are so done with it, we just want to be done. But for M55, they have added some really nice appendices. They included some model specifications. And of course, Dan mentioned that there are some engineering specifications you can get from the PE Alliance as well. They talk about seismic performance. One of the things that we have found, especially as we think about climate change and the impacts of a different Earth than we have had maybe for the last 50 years, is how does PE pipe perform in a seismic environment? Marine installations, of course, that is a really important topic if we're thinking about crossing rivers or streams, or even large bodies of inland water, of coastal waterways. Case studies. This was so nice for AWW to add. There are 23 case studies in Appendix D, and certainly worth using as a good resource as you think about your own work. And finally, we talked about that the PE 4710 data is included as well. And there's your web address if you were interested in ordering that book from AWWA. And then lastly, they did add some other references to external things from AWWA, but I think they're really useful for a design audience. They have added the PACE reference, which helps compare ductile iron, PVC, and HDPE applications. It's a really good design point or design starting point. Also is a good reality check. So that's a nice program to use. It's free at the Plastic Pipe Institute. The HDPE app is also a good starting place. It looks at how will this system work for me? And finally, the bore aid, which is helps you think about, if I'm going to do a trenchless application, what kind of boring information do I need? Not boring as in dull, boring as in how do we put it together? Richard.
Yeah, and for everyone that's just starting out, this is a great reference point. And like we say, we're not trying to reinvent the wheel here. These have all been thoroughly looked at. They've been approved. They've been hashed over by the entire industry. So we're all trying to speak the same language here to keep things on a standards basis, even keeled. And I think they're great tools. And I encourage you, please just play around with them. They don't take a lot of your time because the information in there is provided very quickly. Your answers are provided very quickly. But if you want to dive into the detail, you can. They'll allow you to click on various aspects of the calculators and you can see where that information comes from.
Thanks, Richard. Certainly it's something fun to go play with. All right, so let's talk a little bit about ASTM. Of course, it used to stand for American Standard Testings and Materials. It's now just ASTM International, and it really does think of itself in that way. Again, this is a peer-reviewed, consensus-based organization, and you have within ASTM, you have producers and you have users, and everyone has a voice in that process. And as standards are proposed and drafted, users and people who are interested have the ability to read them and to vote on them and to offer comments and to offer suggestions. So the process sometimes takes a really long time, and we'll talk about a little bit about that here in a second. But at the end of the day, what ASTM standards do convey to the marketplace is this is what people who are experts in the field can share with you about good design and good decisions and how things are organized. And so one of the first ones we'll talk about was updated this year, D3350, and that deals with the material classification. And this really supersedes, you might sometimes find D1248 in some standard specifications. And that if you have that still in your specifications referencing D1248, please consider changing that, because D1248 is no longer a good reference point for piping systems for your municipal applications. 1248 really covers wire and cable, so it does not deal with pressure pipe. Please consider changing your standard to be D3350. And this really is the primary properties of the material itself. All very organized neatly in D3350 and recently updated. And in addition, then we've also had some updates to some oxidative resistance. We touched on that here with M55 a second ago, but Richard, you want to talk us through the oxidative resistance?
Yeah, I mean, a little bit of history here for anyone who hasn't heard this before, but I gave an example yesterday of the Nevada failures that we had in service tubing. So one of the, really what was related to was slow crack growth and oxidative resistance, which we refer to in our world as slow crack growth. So it's SCG. So this slow crack growth failure mechanism was known and understood by the polyethylene groups, but in Nevada and in these hot arid areas, these tubings got very, very warm, especially facing on south facing or west facing homes, which came above ground. So the water got very hot, and so the chlorine or the disinfectant inside that tubing became very, very aggressive. And so when we look at oxidative resistance, we really had to open our eyes to say that, okay, well, what caused this? You know, what was the true factor? Well, one was elevated temperatures. Two was elevated, they had fairly high pressures in that area as well, so operating pressures. So then your hoop stresses applied with the oxidative effects were really important to understand for us, which we now look at as an ORP, or an oxidative resistant potential. So now what we've done here is this particular test method was developed to really, really look at how polyethylenes perform. And so now what we've done is created a classification, which is now included in the D3350. So, or the Astm D33, but it's not a cell class, but it is a cell classification as C1, C2, or C3. And that's a different level of oxidative resistance that these oxidative disinfectants have on anything. It could be any type of material, not just polyethylene, but anything. But we really now understand how it truly affects our products today. And they're related directly to the slow crack growth performance of those generations of polyethylenes. And so with the amazing science and engineering done through this understanding of how it can negatively affect performance, the resin suppliers went out and developed products that would resist that as well. So they've really, really changed and improved the product, which puts us in our fourth generation, which is referred to as ASTM D3350 PE4710s. I think that's probably enough. I encourage everybody to look at this. It's one of the most popular questions that I receive on a regular basis. What is the oxidative resistance of polyethylene? And it's great. So the Municipal Advisory Board and PPI developed these technical notes to actually explain to you exactly how this came about and these studies and how they were evaluated. So don't take my word for it. Take the industry's word for it, that this is the science and the engineering behind the development and understanding of oxidative resistance of disinfectants that are needed in our product or our piping systems to keep people safe. We don't want to have another Flint situation, so we want to do that. So you can see that the TN43 and the TN49 were both updated, and the TN44, which was 2015, was the document put out of really how it was recognized, and then how the C906 incorporated these disinfected aspects into it. Next slide, please.
Perfect.
So specific to C906 pipe, this is of course 4-inch and greater, 4-inch to 65-inch, which is the AWWA standard for how we look at these models of resistant chlorine and for given conditions. So what we did is we solicited something, I think it was something like 425 utilities across North America, looking at all facets of pressure, temperature, pH, chlorine concentration, and residual chlorine concentration, and really looked at all of these aspects to develop a calculator that we could literally use to determine what this ORP effect is on the pipe. So what is the value? What is the chlorine having an effect? Because we know a disinfectant or an oxidizer affects everything. It affects steel, it affects PVC, gaskets, everything, our skin, everything. So we want to truly understand why and how these situations of operation in a piping system would be affected. So the C906 was rewritten and redeveloped based on the science and engineering of the studies that were done with the industries, which basically lead back to TN44. And we can now understand exactly that and start to predict life cycles. And this is where a lot of our, as far as oxidation time goes, this is where our greater than 100-year life cycle now starts to come from in our PE 4710 materials, or 4th generation materials. Next question, or next slide, please. And no questions, by the way. We haven't seen any questions.
I know. I'm assuming Matt's taking care of all the questions.
Yeah, don't be afraid to throw those questions in there, guys. I know this is a lot of information we're throwing at you, but please, we love the questions and we love the information. So from C906 to C901 for smaller size tubing, this is a big update for us, because from our learnings and from what we discovered over from 3rd generations, and it doesn't mean your 3rd generation polyethylene systems in service today are not good. It's just we understand them really well. So if you're in a Nevada area or you're in a high affected area where the pressures and the chlorine effects and everything are very, very high, you can understand that. And then maybe if you need to look at replacing those, you can look at what to expect from a service life out of them. But one of the key things here is that the C901 for small diameter, especially service tubing, we really took a hard look at, because this is where the failures occurred. We have never seen a slow crack, or I've never seen a slow crack growth failure in a service or a main, but I have seen them in the tubing. Just because of the situation that we're dealing with, either higher pressures or lower higher DRs, like maybe they used a DR17 because the pressure was very low. So you have thin walls affecting that product with high chlorine concentrations or higher temperatures. So please keep in mind, in the C901-2020 version, we will only recommend DR9s for the service tubing, and this is to add extra protection. And the reason for this is not because we want to add an additional safety factor, is when, as a pipe manufacturer, when you get into those smaller service tubings, your tolerance for acceptance in the range of thickness that you're allowed becomes very, very narrow. So we do not want to have any failures based on maybe the potential, and I say potential, of poor manufacturing below min wall. And that's why we're moving it up to DR9, which will give you that built-in safety factor to give you long service lives greater than 100-year under normal operating conditions. Next slide.
Perfect. 14 and 61.
All right. So with disinfection, of the second most asked question of me as a pipe manufacturer is, we hear that plastics leach out bad things into our water system. So this is what NSF is for. The National Sanitation Foundation and ANSI have two standards. They have the 14, which really looks at the polymers and their components and the related materials associated with them. So they're not only looking at the performance of the product and how it will react under certain conditions, they're also looking at the health effects as well. So there's two factors there. There's one, the factor that it's in your system and how it's going to function as a operating tool. And second, how it's going to positively or negatively affect health effects of humans, which is probably the #1 priority. So that's code 14. It's a very stringent code, but most standards that I see in municipalities and utilities utilize the standard 61 because it's directly associated with health effects. And for me as a manufacturer, what we do is we get these knocks on our door from NSF at any given time, no warning, no initiation to say that, hey, you know what, we're coming to your place next week. They just show up. And when they show up, we have to accommodate them. And we have to accommodate them with open arms, which we do. And there's an important reason for that is because it's random. It's their randomness to be able to sample any plant, any line, any pipe size, anytime they want. And they can do it up to 8 times a year, which, by the way, I have to pay for. So that's the even added kicker for me. But we welcome it with open arms because we do not want to have any negative health effects of the way we manufacture the pipe into its final usage product. So we want to make sure that they're taking the best samples possible to make sure that they're evaluated to the best of their ability. So, and funny thing is, I just got a call from Lincoln, Nebraska today, and he had that question. Well, there was a question in one of his group meetings to say, well, you know, NSF is great, but how do they know if they're testing for something that they're not testing for? How do they know it's not in there? Well, the answer to that question is, and I contacted NSF about this, and they said, look, we use a test procedure called Ftir, which is Fourier transform infrared spectroscopy. So if anything is detected outside of what they're testing for, it'll show in a peak. So then they'll go look to see at what wavelength, what the possible contaminant or whatever that item is in that particular water sample that they've taken. And they've tested it in extreme conditions. They tested at 90 degrees Celsius for all you non-Canadians out there and non-metric people, that's about 184 degrees Fahrenheit. For over 32 days, they let that water sit stagnant in that pipe. And then they give us a result back that says, here are all the items that we look for, and here are all the items we detected. And I just showed the report. There was really nothing that they detected. There was 2 items they detected below 0.1 part per million, which is just above a detection level, but well within the health factors that we don't have to be concerned. So that's NSF. So I just want to give one last shout out that these products are very, very highly regulated, and we don't look at it from our perspective. We look at it from your perspective. We don't want you to have problems. If you don't have problems, we don't have problems. Thank you.
Sure. Richard, thank you. I thought you did a nice job covering those. And as specifying engineers, our first duty is to protect the public. So I appreciate you taking the time to share with us really how these products are designed, tested, and certified, really, that they can be in places where our human health is intersecting. All right, we will come back to ASTM, I promise you. But for right now, we're going to turn our attention to the Plastic Pipe Institute. And they also have a really great reference out there for you. It is the PPI Handbook of Polyethylene Pipe. And you can download this at no cost, chapter by chapter at the PPI website. It covers all aspects from design to construction to installation to maintenance, a lot of the same information that you might find in the M55 reference. And again, this is a place where you don't need to be reinventing the wheel. Certainly, we address material and the standard specifications that you might want to use as you're thinking about a system, how you design it, installation, really soup to nuts again on polyethylene pipe. In addition to those chapters, you also have the marine installations, some horizontal drilling information, ducting and conduit. We see that more. It's probably not really intended for the audience we have with us today, but there's certainly a chapter there. And you can certainly download any of these directly from PPI. In addition, they also have the municipal guidebook for field manual for municipal water applications. Let's get the word out. This was written in 2009. It looks at both service lines as well as distribution piping. Again, just another good reference for you as you're thinking about projects using polyethylene and how it connects to your systems. They think about size, also about the safety. How do we actually, to Richard's point, flush it, deal with contaminated soils, because you may have systems that might intersect with contaminated former gasoline stations, et cetera. And then how do you store that pipe in your yard before it's time to go install it in the field? Continues, really separates between water service lines and water distribution piping, deals with transitions to non-polyethylene systems, how you connect it to a main. Really anything that you want to know about the installation of a system, this municipal guidance book is a good place to start. And finally, how do you leak test? We'll talk more at the end of our presentation about maintenance and repair, but certainly electrofusion can be a part of that, or a flange or a mechanical joint. Richard.
Hi, sorry, Deanne. Just for field testing, one of the biggest things that I've been addressing the last couple of years is just pipe temperature. Just remember that if your pipe temperature is above 80 degrees Fahrenheit, then we need to look at that to establish your 1.5 times or whatever your greater pressure you want to use for that test methodology. And we have information on that as well. But just throw that as a caution to remember that, because all of our testing is done at 73 or ambient temperature, and then we extrapolate from that either down or up, depending on the temperatures being used.
Yeah, great point. Thank you. Okay, so let's talk. Get all these in here. Sorry about that. There you go. So when we really think about what we're trying to accomplish with any of our projects, it's really a combination of how do we put the right quality control around the material in the process, put the right material with the right equipment, with the right operator, with the right procedure to know that what we have in the field is a qualified and a quality fusion joint. And remember at the beginning, we talked about consistency, safety, compliance, and reliability. So between AWWA and PPI, those handbooks have helped create some standards that now live at ASTM. And in some cases, ultimately, especially for our natural gas customers, gets incorporated into regulation at some point. So PPI often is one of the first places that the start of a standard begins, and we will talk a little bit more about that when we get to F2620. But for the rest of this presentation, I'm going to kind of think about this from a standpoint of how do these standards fit into an overall quality framework. So the first place we want to talk, we've already talked about qualified material when we talked about D3350 at the beginning. We talked about how that oxidative resistance is incorporated into D3350, C901, and C906. So let's talk about the operator side of this. ASTM has a standard F3190. It was updated in 2021. And it deals with training operators for butt, fusion, saddle, and socket. And if you don't know what those are, we'll have some pictures of those here in a second. It requires a written exam, a practical exam. You actually have to make fusions, and those fusions are destructively tested to be sure that you really do know how to make a fusion. So F3190 is a great place, especially if you're writing specifications, to think about incorporating 3190 as your requirement for those operators who are building systems within your infrastructure and within your municipality. With and that was, of course, updated recently. From an installation perspective, D2774 is a great operation, a great standard to use for those underground installations. If you have an engineer that is looking for just a standard installation guide, this is what I would recommend to you. Again, ASTM, industry standard, consensus-based, recently updated, has all of the information that you will need for installing a good system. So as we think about putting a PE system together, there's really several options. We're going to talk about electrofusion here, and then we'll talk about heat fusion in a second. Electrofusion is socket or saddle. Those have operator experience requirements as well. Those are usually driven by the manufacturer of the electrofusion equipment itself. There is a joining process, there's equipment, and there's procedures, and those are all covered within F1290, recently updated in 2019. It's what a electrofusion fitting might look like. And then of course, you could have saddles as well. Alan, what do you want to add for us?
Well, I just wanted to make sure and clarify the actual process on a molecular level, whether or not we're butt fusing, doing electrofusion, doing any type of fusion is all the same. So the resin is actually all treated in the same manner. It's just each step then requires that specific treatment as we follow through it. So Deanne is totally right to talk about all of the qualifications, and it's important and essential to make sure that our people are qualified to do so. So this is right on and perfect. Good job, Deanne.
Yeah, no worries. But that's a great point. Whether you're preparing that area for an electrofusion joint or for a butt fusion socket or saddle fusion, it very similar. You're basically melting the material so that it can be rejoined together under pressure. Great point. So there's two guides out there I would point you to from a standpoint of installation guides, both done by the Municipal Advisory Board. One is for 12-inch and smaller, and one for 14 to 30-inch, MAB1 and MAB2. Those are really nice generic standards. If you don't have guidance from a particular electrofusion manufacturer, these are the go-to references.
And they're free.
And they're free, of course. Good point, Richard. All right, so then from a procedure perspective, of course, heat fusion. And this is F2620. I've given you the -20 reference here. Full disclosure, there is a second update in 2020, that's 2020A Epsilon 1, but it really doesn't apply for those of us working within the municipal environment and the water environment. It was a very specific ad for some natural gas type operations with regard to heat or temperature. So I have not included that here, but just full disclosure, there is a 2020 little a Epsilon 1. We'll talk about 2020 because everything with the exception of those two sentences is exactly the same. So this standard covers socket, saddle, and butt fusion as well. So these are good pictures for you to appreciate socket, butt fusion, and then of course saddle fusions as well. It was updated in 2020, of course. One of the this is a kind of a little bit of a history step. So when polyethylene pipe began its rapid use within the natural gas distribution industry, PHMSA was doing their inspections, and they came to then PPI and said, look, we have inspectors in the field, they're inspecting systems, everybody's procedures are different. Can't you guys, you the industry, standardize on a procedure? So PPI was the natural place to bring those groups and manufacturers together in order to get to a common standard. And that ultimately became TR33 within PPI. TR33 is no longer being updated. It is a historical document. But F2620 was the outcome of the work that PPI did under TR33. So F2620 points us back to our historical roots within TR33, realizing that is a historical place. From a standpoint of things to include in your specifications, certainly a more appropriate reference for your specs would be F2620. The things that we have seen in this new 2020 version, it incorporates the guided side bend for pipe that has greater than 1-inch wall thickness, incorporates F3124 for data recording, and that 3190 for operator that we've already discussed today. It is primarily, a lot of it was just a good cleanup of the language. It did clarify how we should cut that pipe, especially for cutting pipe to put it into a machine that we don't want to have oil on it that gets transferred to the facer. So that's included in F2620. From a standpoint of the procedures and the temperatures and the time and the bead size, those things have all been very consistent since about 2012. And it still does indicate that fusion joining is not recommended in ambient temperatures below -4. I don't want to be out if it's -4, and I'm sure that you don't either. So no, I don't think that's too bad of an idea. Richard,
Oh,
you
come
want
on.
to be out
Oh,
there?
come on.
You don't want to be out
Well,
there,
you-
buddy.
Yeah, well, you know what? You can go down to -20, but you have to take precautions and do things
right.
properly. But there's, again, as ambient temperature changes, which is a valid point, the conditions have changed. So you need to understand that thoroughly.
Right. Good point. Some projects that are in the works, and I don't know that it's going to be be especially of interest to this crowd, but I will note it. PPI is currently working on some guidance around fusing different wall thicknesses. F2620 deals with a difference in outer wall thickness of up to 10%, and that is certainly still fusible within F2620 as it's written. But there's some work being done at PPI to address truly different DRs so that your inside and outside diameters might be different. So just wanted you to know that that work is in progress. Within ASTM, there is the PE reverse bend back. So this is something that we often see incorporated into specifications, that the first joint of the job or the first joint of the day or that an operator needs to demonstrate. Basically, they fuse a joint, you take the joint and you do a bend back test on it to confirm that the joint has been fused correctly before the day starts or before the job starts. So that's incorporated in this PE reverse bend back test is incorporated into F2620, and it's certainly something to consider as you think about your specifications for quality control. And I know, Alan, you wanted to talk about what we might do about thicker walled pipe. Is this what you would want them to do?
Yeah, no, that's not it at all. So I'm definitely glad that you pulled that on for this time. Well, you know, a lot of great things start with, "Hey, y'all, watch this," but that was not really one of them in that scenario. So we do have the guided side bend test that you can pull through in order to be able to make sure that the quality control is in place for you. Deanne had done really well mentioning that, hey, if you get a new guy that's out there doing or gal that's out there doing the fusion, you want to test it, then yes, you can pull through and try to do this test. And this is another test that's available to you for larger diameter, larger thickness tests for you here. So ASTM F3183-16 here. As you can see, what we're doing is we're cutting a piece of this pipe out. We're making sure that it represents exactly how we fuse that pipe to begin with. They're not going to do anything different. And then we want to be able to go through this process and bend it to see whether or not it's actually going to pass that test. So McElroy, of course, makes fantastic equipment. A lot of times they improve and continue to improve and continue to improve the things that they are building for us. And so this is an example of the testing mechanism itself. Once you get that strip prepared and properly ready to go, this hydraulic apparatus will do it right there for you, so you could see whether or not this will pop and fail.
Yeah, I think we have a video of that.
I think so. I think our fearless leader, Pete Dyke, couldn't join us today, but he's doing so via this video.
Peter
so
Dyke here from the PE
certainly
Pipe Alliance.
enjoy
My
it.
colleague Bob Hack. Peter Dyke are going to talk about McElroy's my colleague Bob Hack and I are going to talk about, for years we've talked about the importance of accountability. For years we've talked about the importance of that engineer knowing on the job site. The importance of that engineer knowing that the polyethylene project is going to be handled in the manner that she intended. Well, we have the side bend tester. This is a destructive test that can be done in the field by the inspector or by the contractor for review by that inspector or that engineer. Bob, tell us a little bit more about the process.
All right, Peter, this is a cross-section of an actual fusion that was done in the field. It is run through a planing device, and we're going to place it into the side bend test machine where a piston is going to press down on that joint to validate the integrity of that fusion.
You know, this is really not only a very cool process, but this is side A, this is side B, this is where the fusion occurred. And you know, looking up close, you can't even tell that a fusion occurred. And that's the beauty of the polyethylene thermoplastic pipe, Bob. But another thing is, once we put this through, if we were to hear a crack or see a tear, we know that the operator probably didn't do his job correctly during fusion. Let's take a look at the machine.
All right, so this piston is right down on top of that fusion joint. And the gauge on the front of the machine here is showing us the degrees to which we're going. We're going to take it up to 90 degrees.
All right, let's release it and take a look at it. All right, how's that look, Bob?
No visible signs of any cracks. We didn't hear any pops during the process.
Yeah, there are no tears there. So this is a good fusion. So we now have confidence to know that that operator, that contractor, the sub or the GC is doing the fusions correctly in the field. We see this on the first fusion of the week, the first one of the month, whenever they change operators, whatever interval the engineer specifies, this can be done. It's relatively inexpensive, so you can learn more about it at pepipe.org. Go to McElroy's website or talk to your favorite polyethylene distributor. Until next time, fuse it or lose it. Greetings. Peter Dyke here from the Greetings.
You're on mute, Deanne. Might want to unmute.
There I am. Now I'm there. I'm glad that Peter got to do that with us. Okay, so moving on. Of course, there's other ways that we can do quality control, and data recording is one that is now specifically incorporated within F2620, that in the event that an operator is doing data recording, what things should a data recording system capture about a project? So ASTM has a standard 3124. There's an open project right now looking at updating it. And the things that ASTM says are important to capture regarding any type of a fusion project is the heater temperature, the pressure during all stages of that fusion. So when you bring those together initially and you do beat up and then you do the heat soak and then you do the cool cycle, what pressures is the pipe experiencing during each of those phases? How long those stages last? ASTM F2620 has standards around that based on the size of the thickness of the pipe for users to be sure that they are comparing their job site to actual F2620 requirements. Who did it? What the job number is and where the joint is. So those are all pieces of equipment, pieces of data that can be associated using a data recording device with a specific job site. In addition, it's always good to capture the equipment manufacturer information, which standard was used. That's a great way to check. And then also what kind of pipe was used? How big is it? What depth did I bury it? And of course, most of the data recorders will also give you GIS information. So now instead of you having to send a survey crew back out once the job is complete, you can actually survey it in real time using a data recording system. Richard, what do you have for me?
Yeah, and this is really important because when we typically produce a string for polyethylene, we do it above ground. So the whole string is done above ground, and then we may relocate that string to somewhere else. So you can actually walk along the pipeline if you put it in the trench and mark those specific joints right at that point. And it's a wonderful, wonderful thing to have. Then you're not guessing where a potential issue may occur or may not occur. Usually it's not, but it's very, very precise. And I think it's just a fabulous, fabulous tool.
Yeah, and it's a real time saver for the field, and then for your data house and on the back end. Okay, so now we have built we've designed a system. We have quality people and trained people that have installed it. We have used a qualified procedure. We've used equipment that is designed for the task. We might have done a data recording on it. How do we test it before we put it into service? And Alan, I think you were going to talk us through how do you know that your system's ready to go into service?
Oh, absolutely. Thank you very much. For pressure testing, much like you would do pressure testing for any other pipe material type, PVC or ductile, what we're looking at is holding that to pressure for whatever that test pressure system is for several hours, period of hours, and then observing whether or not there's added water to it. So they'll seal up. One of the unique things about high density polyethylene, especially if you get to use a trenchless application, is you can do this above ground for a long string, a pipe string, to be pulled into place all at once. And that can be 1,000 feet of pipe. It depends all on, of course, the length of the trenchless run that you're doing. So an interesting thing about polyethylene with regard to pressure testing and what's called amended water. So if the system has a leak somewhere, they have a formula that determines exactly how much leak there can be, and the operator performing the pressure test can add water to the system. High density polyethylene doesn't leak. So what they do with HDPE above ground, there's thermal effects. So sometimes it can expand. So that's unique to HDPE in the fact that the operator then has to know that if there is amended water during that process, it's because that high density polyethylene has expanded due to thermal effects. So one of the things that we do here in Florida, where I'm talking to you from today, is just pressure test in the morning. And that way you won't have that sun's effect all day long on it. And it's pretty straightforward to go through. Next slide.
You bet. Oh, sorry, there we go.
Oh, that's okay. This is the similar thing. We're just looking at using gaseous testing media under pressure as opposed to a water test in that nature. So this is a little less common for municipalities. If you're looking at doing an air test or something similar for gravity sewer, this might be how you would test a buried gravity sewer system already. But this is here to show you that there is an ASTM standard for that, and it's available for you to be able to test this pipe any method that you want to. Go ahead.
Which way would we recommend though, Alan? Would we recommend either a hydrostatic or a pneumatic? Which one would we recommend?
The majority of municipal applications on the line here are going to go through the hydraulic and the water test as opposed to different one here.
Yeah, I agree. I think if a system cannot have any moisture introduced into it, that might push you into a pneumatic system, but hydrostatics is certainly a whole lot safer than doing a pneumatic test as well.
Absolutely.
Yeah. Okay. How about some ASCE stuff, Alan?
Oh, that's good. Good. Yes. So in addition to the ASTM standards that we've talked about here, ASCE has many manuals of practices as well. So I did mention trenchless technology, which is 90% maybe of people's first introduction to high density polyethylene. If you haven't used that process or pipe material previously. So if you're looking for guidance outside of AWWA, ASCE is your preferred manual. There is also here MOP 108, which happens to be a horizontal directional drill, again, which uses a far amount of high density polyethylene for the actual installation. The MOP on pipe bursting is about 112, as you're shown here. Now, pneumatic and static pipe bursting are the two primary types of pipe bursting. And I'll just state that pneumatic pipe bursting, which uses an impact hammer to pull that pipeline along, is only able to use high density polyethylene. So within the pipe material types that are available for you for pipe bursting, high density polyethylene is primarily going to be your go-to pipe on that. They also have an MOP 125 for just general conveyance for water and drainage. So this is going to be your stormwater pipe. This is also going to be open installed, open cut excavation for any pipe material type. So there you have it. There's more basis for you.
Perfect. Thank you for covering that. It's a really great reference as well. Okay, so quick. This is not one of Dan's questions. This is a one for you to answer to yourself. The most common question that we might get or pushback against polyethylene pipe And if you're not sure what your answer would be, I'll cheat and tell you this is the question that we get asked quite a bit, is how do we repair it? So all kidding aside, really that an HDPE system is leak-free, it is intended to be, but third-party damages can happen. And the question is, how do you repair it? Municipal Advisory Board, of course, has a guidance document for us. It's the basic repair options. And they looked very closely at this question and really treated it with the seriousness that the question is asked. Is really, I'm a system operator. I need to know how I'm going to repair your system. So the first thing is, if you can stop the flow of water through it, then fusion is your first choice of repair, because again, you're replacing that which is a current that should be a leak-free system, again, with something that is going to be leak-free. Squeeze off tools. And if you're not familiar with what a squeeze off tool looks like, we have a picture of those and a little conversation here at the end of the presentation. If you end up needing to use a mechanical fitting or a coupling, those have to have some pull-out resistance and restraint, because otherwise they will separate, and then we'll be back to square one. And anytime we use a mechanical coupling, of course, internal stiffening is important. And then they walk us through some other questions that we need to think about. If we have metallic, of course, we're going to need corrosion protection. An HDPE system on the whole does not, but of course, if we have metal, those would have a corrosion protection need. If we use fittings, we want to have something that is 1 DR thicker in order to have the same, and to have the same pressure rating. They give all sorts of really good examples. I'm going to just give you a little flavor of what you can find in this MAB basic repair document. It is flow chart driven. What kind of leak do I have? Once I know what kind of leak I have, then what are my options for how to repair it? And if that's my option of how to repair it, what is that going to look like when I do it? So a really, really great reference for both our design engineers as well as for our maintenance teams as they think about what things we want to have in stock, or how to train our maintenance personnel on how to identify the next step or the next course of action. That has all sorts of configurations. I really give MAB a huge credit for taking the time to build out this resource. It saves a lot of Google searches on the part of the rest of us. So again, just lots of really, really great examples of how to put a system back together in the event that it's needed. Squeeze off tools, and we can certainly talk more about this, and maybe Matt has some questions around this one that have been raised in the chat. But this is what a squeeze off looks like. Of course, if you are doing a squeeze off, it is super important to follow the guidance of how long. So this is a good picture of one.
I would like to add, if you notice, I put the tool at least a foot away from a butt fusion.
Yep, I think that's all we get of this one. But there are certainly standards out there to help us with how long a squeeze off should take, and that's a function of pipe wall thickness and diameter, and also temperature. Alan, what would you like to add here?
We've had a good question about pressure testing. So the question here came: is there any way to verify the integrity of the pipe if the hydro test pressure exceeds the pressure surge, or is it just deemed a failure and pipe cannot be used? So I wanted to just take a step back on high density polyethylene itself. So surge pressures with high density polyethylene, the pipe itself is actually rated to 1.5 times the operating pressure of the pipe for recurring surge. So that's about 50 cycles a day that can happen. And then 2 times that operating pressure for the occasional surge. So what that typically means within the operation of a municipal water and wastewater system is that's the recurring is the pump on, pump off, valve on, valve off, that type of thing that happens as we routinely move water through a charged potable water system. And the occasional surge now becomes the all pumps on, all pumps off. So that's going to be like water main failure when the pumping equipment is actually responding to water moving through the system, or all pumps on, all pumps off, that type of thing that happens when we're doing a firefight or something of that nature. So again, if we're rated for 200 PSI, we would be operating that pressure test at that pressure test rating, or 1.5 times the pressure test rating, to look for that. And then the surges, again, are that 1.5 and 2 times. That's for the lifespan of the pipe. There's a difference of what we see in the actual field. And a lot of times, even though a DR11 is rated at 200 PSI, the only operating pressure within the utility is 55. So there's conservativeness, not only in the material design, but also in the operating pressure that we'll put through there. And I could tell that Richard is just chomping at the bit to come here and add, and he's right there for you. And that's one of the beauties of having all of these experts here with you as well. We get to talk about a lot of these things, and you're writing some great questions. So thank you guys all very much.
Yeah,
Let me jump in front of Richard. Richard, real quick, let me jump in front of you.
I've lost control.
As Richard goes on provides us with some color here, I'm going to go ahead and launch the second question. Deanne, we got about a couple slides left, but before everyone starts to take off, I wanted to see what, after everything that you learned today from Deanne, what part of your specification would you be most likely to review and revise? So I just launched that poll question, and that helps us know what you guys are valuing most when you're considering your specification. So go ahead, Richard. That's my 2 cents.
Okay, just to add to the question of if you overpressurize. First and foremost, if you overpressurize the pipe, and let's say it doesn't fail, but it does expand past yield, and you do have some deformation of the pipe. And I've experienced this in the gas industry a couple of times where they tested pneumatically, where they didn't take into account the compression of the air, and they did overpressurize the pipe, but it failed. So they're going, well, can I just cut out the failure, or do I have these bubbles all the way down the length of the pipe? My recommendation in this particular case, because it was only 3-inch diameter and it was DR7, so it's fairly thick walled, is they actually ended up pulling up 3 miles of pipe. Unfortunately, because we can't guarantee, because you can't send a camera down that small diameter to see if you have any deformation of the wall and interior of the wall. If your pipe is big enough, and you've got it in there, and you want to, and you can camera that line, you will be able to see that deformation. So if it only deformed in one area, which is usually the thinnest part, then you'll be able to see those other areas where it deformed, and you can make a better decision based on what you see in that pipeline. So there are things to do it. That's why we don't really like to use the pneumatic side of things. We'd rather use the hydrostatic. But keep in mind, as Alan said, if you go over the MOP, let's say to 400 PSI on a DR11, I'm not too concerned.
Perfect. I bet that would have answered those questions. I'm so glad that you were here to add that color. Thanks, Richard. All right, I think we have maybe 2 or 3 more slides left. And if you are capturing slide shots, these are probably the ones to capture. Just the good references of the things that we have talked about today. The PPI handbook, of course, the field manual, the various organizations that we have spoken about today, PPI, ASTM, AWWA, there's no surprises in this list of characters. And then also the references that we have additionally talked about today, just so that they're all in one place for you as you're thinking about building out your standard set. It'll be interesting to see the answers to Dan's poll. I'll let Dan chime back in here in a second on what the results of that poll might look like. So those are, I don't know what, there we go. There's the references. I think I gave that one to you. And then the final resources, Alliance for PE Pipe. My contact information was at the very beginning of the slide. It's ddhughes@mcelroy.com. Happy to answer any questions that you might have following the presentation in the event that Matt or Richard didn't get those answered during this session. And Dan, you want to join us back in here, or Alan, and give us a final tally and final wrap up?
Yeah, it looks like 50% of people said that specifying pipes, fitting, and equipment that meet the industry standards would be their preference. But 32% also said making sure the pipe is being installed by properly trained operators was the most important. And that is something that you guys handle at McElroy, right? Qualifying operators. You want to talk about that briefly?
Yeah, sure. We have McElroy University, and it is a way to train your operators as well as your maintenance crews that are going to be working on your machine. We have maintenance classes, as well as you have group people that you want to certify as the inspectors for your equipment. We have courses around that, and those courses are taught here in Tulsa, partially online and partially in Tulsa, but those classes can also be accessed through many of our distributors around the country. So yes, thank you for the opportunity, Dan, but the training is specific to large or small or medium diameter, and also specific to the type, whether it's butt fusion, socket, or saddle. So depending on what your operators might need, you can really tailor the training specifically to the work that they're going to be doing.
I've been through that training before, and it's fantastic. You guys really take it seriously and do a great job providing answers and illustrations as to how to use the equipment. We did have another question that came through about squeeze off and maximum pressure. Matt Hahn had answered that through typing, and everyone out there, thank you very much for writing us your answers. But yeah, the squeeze off tool actually migrated to municipal use from the natural gas sector, which was very, very common to be able to squeeze off to do whatever work you're doing, and making sure that the gas material doesn't obviously come through that. Very, very robust. And when we talk about these larger diameter pipes and a hydraulic unit, and it's interesting in rehabilitation stage, if we're rehabbing an existing pipeline, as you're getting and moving through that, either through a pipe bursting job, or if you're open cutting and replacing it, yeah, you have to control the valves to make sure that the water flow goes through there. And oftentimes the contractor, whoever's doing the work, will leave in a temporary construction valve to make sure that they have adequate control over which sections that they're working on that are dry. This squeeze off tool can eliminate that. So that's part of one of the true benefits of the squeeze off this way. And again, we're not deforming or hurting the pipe beyond its allowable yield once we follow the ASTM standards that control that, and that pipe section is going to live the rest of its life through as designed. So it's definitely a robust pipe material product that will let you do that. We're not going to be able to squeeze off any other pipe materials in that manner. So definitely great questions for everybody, and we're so happy that everyone's here for us here. Anything else to add, Richard or Dan?
Last thing is, I just want to ask people really quick to take the survey at the end of the presentation, just letting us know what you thought about today, and if you have any question about your specifications, so we can help you with. Go ahead, Richard.
Yeah, and Dan, we did have a couple of questions of whether this presentation was available to them for their lunch and learns. You can work through Dan and Alan through that one, and again, at the end, great job. I'm so glad everybody has these questions. They're very typical questions that we're exposed to, and again, the experience that you gain from them, I hope they were all answered properly. There was one question on the greenness of polyethylene and during production. It's all electric equipment, but I think there was a study done by PPI, and if any of you know the study results from that, I know they were trying to compare legacy production versus polyethylene production to see if there was a difference. I'm not sure if it ever finished or was done, but I can tell you that plastics are very green from a resin manufacturing, if I put my resin manufacturing hat on, because we take the ethylene out of the air that they used to burn off in refinement. So we've captured all of that and reduced that immensely. If we can just stop the littering, we might be okay to stop all the microplastics and everything else that's happening, because a lot of the cases, you know, the job that Clean Oceans are doing is fantastic. That young gentleman from MIT, I think he's from, is doing a fabulous job in cleaning up the pollution that us humans have created. It's not the plastics that's the problem, it's the human problem. So hopefully we can take care of that properly and be responsible, because I know the plastics industry is responsible with responsible care programs and everything that they have in place. And we hope that we can continue to benefit the human society moving forward.
Sure, Richard, I can answer a little part of your question. PPI has recently published its sustainability paper, white paper, and it's on the PPI website under sustainability. So you can access the PPI's current sustainability information at the PPI website. And of course, polyethylene pipe is 100% recyclable. So if you have whatever drops from the ends of your construction, if you're using a line tamer and you have that part at the beginning that's too rounded or too curled in order to fuse it and you've cut it off, those pieces of pipe are absolutely recyclable. It is polyethylene, no different than any other polyethylene, and can certainly go to a refiner, should be either reground and made back into polyethylene pipe or made into other things that are polyethylene. There's some rules for pipe manufacturers about what types of products they can make that include recycled material. It can't go back into gas pipe, can't go back into many forms of our pressure pipe systems, but it can certainly go back into conduit and it can go back into gravity feed systems. So it is very recyclable, whether it is 10 minutes from being used or whether it's been in the ground for 100 years. Anybody else have anything else? All right, Dan, great seminar. And Matt, thank you. Matt, you were the quiet, silent partner today. Thank you for being online to answer questions.
My pleasure.
And certainly appreciate all of you for joining us today, and reach out to Dan with any questions, or and I'll make a plug for him for you to also finish that survey for us. Appreciate everyone.
Great job, Dan. Thanks for taking care of us today. Appreciate it.
Thanks, everybody.
See you guys.